of linear graphs. So we've done straight lines plenty of times, that's why it's a review. So linear just means straight. So it's on the top of the page there. A linear graph means that it is a straight line. Finding the intercepts. So if you're wanting to find the x and y intercept, you're going to let x equals 0, you're going to sub that in and find out what y equals. And then you're going to sub in when y equals 0 to find the x-intercept. Remember doing that? Let x equals 0, let y equals 0, and you find your two intercepts. There are two different ways that you can give the equation of a straight line. First of all, we have the gradient intercept form, which is the y equals mx plus b that we're familiar with, where m is the gradient and b is the y-intercept. The other way that you can leave the equation is the general form, where everything is on one side of the equation, the left-hand side, and you want the x, the y, the constant equals 0. There shouldn't be any fractions in your numbers. You should always make sure you multiply them out if there's any fractions, so whole numbers for your coefficients of all of those things. And that is general form. Then the next thing on there is the different methods that we have for sketching straight lines. First of all, the first time you ever sketch straight lines, you use a table of values. So there is always that option. There's an example, there's a table. You sub in the x values, you get the y values, and you can plot all the points. Okay? Hopefully we won't be needing to use that one too much anymore, because the second and the third method will hopefully be much faster. The second method here is to sketch using the gradient intercept method. So if your equation is in the form y equals mx plus b, you find the y-intercept first and you put that on your graph, and then you know the gradient, which gives you a rise and a run to do from that point, from your y-intercept. Okay, so that's the second method. And finally, the third method we've already discussed, which is finding the x and the y-intercept by subbing in x equals 0, subbing in y equals 0, finding those two intercepts to put on your graph. You can only ever use that method, however, if your line does not go through the origin. Okay, otherwise 1 point is not enough to sketch a straight line. You need at least 2. All right? All lines except vertical and horizontal lines have a domain of all real x and a range of all real y. Okay, we talked about domain and range last lesson. And lines specifically, as long as they are sloping lines, not your vertical or horizontal, they will be all real x and all real y. Vertical lines are always x equals a number, because it's x-axis, you're going through the x-axis at that number, so they're vertical lines. Horizontal lines is when it's y equals a number. So y equals 2 going through the y-axis. Horizontal lines through the y-axis at that number. All right, that's the theory part. Example time. Sketch the graph of y equals 2x minus 3. State the domain and range. So we see the equation. Hopefully when you look at the equation, you would know that that is a straight line, normal x, normal y, and it's even in the y equals mx plus b form. Okay, so because it's in that form, let's use that method where my b is going to be the minus 3 on the end, and my gradient is going to be the 2, which is in front of the x. So to sketch that line, all I need to do is have a lovely drawn Cartesian plane here. My y-intercept is at minus 3. So 1, 2, 3, minus 3, putting across there. A gradient of 2, remember you need a rise and a run. Any whole number is going to be over 1. So that would be 2 over 1. Just trying to rub out my arrow there. Can you see that? 2 over 1. So that I rise 2 and I run 1. It's positive, so you run to the positive side. So from the minus 3, that's your starting point. Go up 2 and across 1 to the positive side, and there is your second cross. Now, if you've drawn that accurately, we should be able to draw a line through them. And there is our straight line. Okay? We haven't finished the question though, because the question says to state the domain and range. It's a sloping line. Okay? So what possible x values can I have? All of them. What possible y values can I have? All of them. Okay? So over on the side here, I'm going to write for my domain, DOM for domain, it is all real x. And for my range, RAN for range, all real y. Okay? Easiest domain and range that there is. On the next page, question 2. Again, we are sketching. This time the equation is written in a different form. That is the general form of a straight line, where we have x, y constant equals 0. Okay, so for this one, how about we use the x and y intercept method? Okay, so let's go when x equals 0, subbing x equals 0 first in to that equation, I would get 2 times 0 plus 3y minus 6 equals 0. Now the 2 times 0, you can cross that out straight away. 2 times 0 is 0. It's not going to do anything. So I have the 3y minus 6 equals 0, which I want to solve for y. So first of all, add the 6 across to the other side. 3y equals a positive 6. Then divide the 3, which means that y equals 2. Okay, that is my y-intercept. So I also need to do when y equals 0 to find my x-intercept. So back to that original equation again. 2x plus 3y, but y is now 0, so 3 times 0 minus 6 equals 0. Again, we can cross out 3 times 0 because that makes nothing. So solving that, I want to move the negative 6 across. 2x equals a positive 6 and divide by 2, which gives me x equals 3. I just need a little sketch of that over on the side. The main thing is that you are showing clearly those intercepts. So x-axis, I have x equals 3. 1, 2, 3. Put a cross at that one. My y-axis, y equals 2. 1, 2. Cross on that one. And then join it up. Okay, domain and range again. It's a sloping line. All sloping lines are all real x and all real y. So write those down as well. So domain, all real x, and range, all real y. Question 3. Sketch the graph of the line y equals 3, stating its domain and range. Okay, for some reason, people always get caught by these ones. When it is just y equals or x equals, they are your vertical and horizontal lines. Okay, so y equals 3 means we need the y-axis, and we need a 3 at the y-axis. So I'm going to draw my axes in green, and then I'll change to blue for the line. So 1, 2, 3, there's my 3. Now it's going to be a line going through 3 horizontally because it's y equals. Okay, so y-axis going through the 3. That's what that means. Now this one's not a sloping line. It's a horizontal line. So we have to think a little bit more about the domain and range for this. First of all, the domain. What x values can I have? Anything. Anything. Good. I can still have any x values out here or here, and I will get a part of a graph that goes with it. So domain. Still all real x. The range. What y values can I have? 3. Only 3. It's the only y value you can have. So the range is just y equals 3, and that's it. Question 4, of course, I have to do one that's an x equals. So we have x equals minus 2 now, which means I'm now going to be going vertically through the x-axis, x equals. So little quick Cartesian plane, x-axis, I need to label the minus 2. So it's going to go through x equals minus 2, vertically, straight down. There's the graph. Domain and range. What possible x values can I have? There's only one, not 2 though, minus 2, but I knew what you meant. So x equals minus 2 is the only x value that you can have for that, whereas the range, all real y. We can still have all values of y. The graph is going to keep going up and down, right? All real y. And one more, question 5. Find where the lines 2x plus 3y plus 5 equals 0 and 3x plus 4y plus 6 equals 0 meet. Now, hopefully all of you are thinking, yep, I can do this. Simultaneous equations. And it doesn't even involve a quadratic. How easy is that? Okay, so simultaneous equations with 2 straight lines. Because we know these are straight lines, we're only expecting one solution. Quadratics, you expect 2 solutions. Okay, so one solution. Looking at the equations, none of them have an x or a y by themselves, so probably easy to go for the elimination method here. So let's rewrite those equations. I'm going to go 2x plus 3y plus 5 equals 0. I'm going to write them on top of each other. 3x plus 4y plus 6 equals 0. Okay, so I'm going to make the x's the same. To do that, I'm going to multiply that whole top equation by 3. And the second equation, I'm going to have to multiply by 2. That will mean that both of my x's will become 6x's, right? So I'm making them the same. So let's multiply through. The first equation, 2 times 3 is going to make 6x, plus 3 times 3 makes 9y, plus 5 times 3 is 15, equals 0. Second equation, we're multiplying by 2. 3 times 2 is 6x, plus 4 times 2 is 8y, plus 6 times 2 is 12, equals 0. Now that I have made my x terms the same, we are ready to eliminate by either adding or subtracting the equations. To make the 6x's eliminate, would I add or subtract? Yeah. Subtract, correct. Okay, so like a big sum, you put a line across the bottom and you put your minus sign at the side. I'm going to subtract those 2 equations. 6x minus 6x is nothing. Those 2 will disappear, gone. 9y minus 8y will make 1y, or just y. 15 take away 12 is 3. 0 take away 0, you do have to make sure that you do that last column, that last row as well, is 0. So all I have to do to get y by itself is subtract that 3 across to the other side, and I get y is equal to negative 3. Don't forget, we still have to go back and find our x value, so you can choose where to sub it. How about the very top green one here? Okay, so that's going to be, I'm going to sub into, sub into 2x plus 3y plus 5. I didn't. You could have numbered it and said sub into 1 or something there. I didn't number them. That would be fine though. So subbing into there, I would get 2x plus 3, replace the y with a minus 3, plus 5 equals 0. 3 times minus 3 is minus 9, plus 5 equals 0. Adding those numbers together, minus 9 plus 5 is negative 4, so 2x minus 4 equals 0. Moving everything away now from the x, add the 4 to the other side. 2x equals 4, dividing by 2, we get x equals 2. Okay, at the end, please write your solution as a coordinate. X is 2 and Y is minus 3, written as a coordinate. That's it. Okay, so straight lines today, you're doing 3C.